When people think of plastic pollution, this is typically what they think of. What if I was to tell you that there's an even bigger issue? It's a bit hard to understand how clothing is an issue, right? We struggled too. So, we launched an investigation into how microplastics are distributed across Pittwater. Scenery's great and all, but we're actually here to work, so we better grab these jars and get sampling. When designing this experiment, we decided to get 9 jars of sediment per beach, plus 1 control jar that was empty per beach. That's a total of 36 full jars and 4 closed ones. Lab sampling was definitely a bit of a process. First, we had to make a salt solution with salt and water. Then we had to put all of our sediment inside that solution and continually keep stirring it up. All the while, we had to make sure we were all wearing 100% cotton clothes and that none of our materials were plastic. The reason for using such a salty solution to mix with the sediment is because the salt water is going to be denser than the microplastics in the sediment will be. This means that the microplastics will float to the top, and when it's poured through a filter, it should, in theory, leave only microplastics on the filter paper. We used Nile red dye to make the plastics in our sample glow under a UV light. Once the samples were dyed, we put them under a UV light under a microscope so we could see what we had found. After all that work in the field and in the lab, we were finally ready to do some statistics. But first, we had to figure out what questions it was we were trying to answer. The first question was, what was the spatial distribution of the microplastics across Pittwater? Was there more under the water, or was there more on the beach? Were they different between the beaches? The second question was, what were the types of microplastics found? Were there different fibres or fragments? Were there more or less of different things? And where did they come from? What we found was very interesting. When it came to spatial distribution, we found that there was about the same amount of microplastics at each beach, but that doesn't mean that there wasn't a lot. The other interesting aspect of the spatial distribution of microplastics in the Pittwater beaches were that in the 40-metre samples, which were under the water, there was significantly less microplastics found. We think that this is because the water churns up the sediment, and similar to our salt solution, the seawater acts as something to push the microplastics to the top. Finally, we looked at the different types of microplastics that were found in Pittwater and how many of them we found. Interestingly, the most dominantly found type was actually microfibers. Microfibers are small pieces of cloth that is not made of cotton, but instead made of a polyester or plastic material. That's right, clothes. I believe if we rewind, I might have mentioned those before. So, as it turns out, there's actually plenty of evidence to say that fashion is the true cause of a lot of the microplastics that end up on our beaches. So, what do we do to avoid it? To start with, you can be more aware of what you're wearing. You want to make sure that you're wearing clothes that are made from more natural fibres like cotton and not from synthetic ones like polyester. And reuse where you can. You can get second-hand clothing from so many different stores these days, and you can swap with your friends, so that when you're done with an item of clothing, they get a brand new one. As for other sources of microplastic on our beaches, such as fragments, films, and microbeads, there are a few simple swaps you can make to help. When it comes down to it, yes, microplastics, specifically microfibers, are definitely a big issue in Pittwater. However, it's not all sad. There are some huge steps that we can all take that are super easy that will help reduce microplastics in our sediment and keep our beaches looking clean and pristine for the future generations.